All right, here we go. This is AP Physics video 2.1 and a half. This is not actually physics, it's really more math. And I think that a lot of you have probably learned some of this calculus, but those of you in AB or maybe even BC probably haven't learned this yet. So this is a super quick crash course in calculus. I'm basically going to teach you the how behind the calculus, and then in your math class you'll learn a little bit more about the why, okay? So here's the deal. So given a function f of x, if you've got a function f that depends on the value of x, it turns out that the derivative of f of x is a whole new function. It's its own separate function, also a function of x. In math class, you probably denote it as f prime of x, and that means it's a new function based on x, and it's the derivative of it, all right? In physics, we're going to use a different notation than this, but that's the derivative, okay? So there's two functions now. There's the function and the derivative of the function, okay? What the derivative does is it gives you, for any value of x, it tells you what the slope of a line tangent to the original function at each value of x is, all right? So, probably easier to explain that by means of an example, all right? So let's take a look at the next page here. So I've got this function, right? So maybe this is my f of x, all right? And here's my x-axis, x, right? Okay? So suppose I want to figure out what f prime of, I don't know, let's do -1 is, all right? So what that would mean is this. It would mean I want to find the slope of the tangent line at -1. So I'm going to find x equals -1. I'm going to find the point on f of x, and then I'm going to figure out what the tangent line looks like. So that a line that is tangent is going to touch that curve at exactly 1 point. So it's going to look something like this. And then I find the slope of that. That's what the value of the derivative is. All right, oops, I wanted that to be purple still. All right, and so the idea is, if I repeat that process for every value of x, if I do it over here at -2.2 and -2.0 and -1.8 and -1.6, and I do that for every value of x, and I repeat this process and keep finding these tangent lines and their slopes, the resulting value of each of those slopes gives me f prime of x. Okay? So, suppose I wanted to find f prime of, I don't know, 3. So f prime of 3 would represent, if I find my x value, happens to be that f of x there is 0, f of 3 is 0, but if I draw in my tangent line and find the slope of that, that would be f prime of 3, would be the value of this slope here, okay? And notice this slope, even though I used the same letters, which is sloppy, is different from this slope, right? Okay? So that's one explanation for it, all right? The other explanation, it really is the same thing in different words. Another way to describe the derivative is it gives the instantaneous rate at which the value of f of x changes with respect to your horizontal axis, x, for each point x, okay? So it basically gives you the slope at every point, right? This is really just the same definition in different words, okay? So f prime at -1, the derivative at -1, tells me how quickly my function is increasing or decreasing at each point. So the idea is that at this point it's increasing at a rate of whatever the slope of that line is, right? Okay, so that's what the derivative is, okay? It tells you basically the slope at a point is the way that most people will say that in simple terms, okay? Derivative gives slope at a point. And when you think slope, you should be thinking change in y over change in x, right? Okay? And so for that reason, so here, usually when you use these deltas, that represents some noticeable change, right? So maybe I want to find the slope from here to here. So this would be my delta x, this would be my delta y, right? Okay, and then the slope would be the slope of this straight line that connects those 2 points, right? Now, so in math class, we call the derivative, so if you're given f of x, we call the derivative f prime of x, all right? more mathematical notation, strangely, even though this is what we usually use in math class, more technical notation for the derivative is this. Because it represents slope, we want to talk about the change in y over the change in x. So it's dy dx, okay? And we've just replaced the deltas with d's to indicate a small change in y at a point over a small change in x at that same point, all right? And I guess technically on our y-axis here we've got f, so you could also call it df dx. And this is actually the notation that I'll be using, all right? Your vertical axis represents some function, and your horizontal axis, you know, is the measure of something, all right? So this df dx is physics/technical math speak for f prime of x, all right? And like it or not, this is the notation you got to get familiar with to be successful in this class, all right? So what do we need to know? Well, let me tell you some rules that we need to know, all right? I keep doing this. All right, so here we go. Here are the rules we need to know. You need to know that the derivative with respect to x of any constant is 0. Why? Well, suppose f of x is, I don't know, 5. Well, the line f of x equals 5 looks like this. And what's the slope of that? Oh, the slope of that is 0, right? Okay, so that is the first thing you know. Anytime you take the derivative of just a number by itself, whether it's 5 or 27 or negative 8, the derivative of that is 0 because the slope of a constant is 0, all right? So that is thing 1. Thing 2, we're going to do this one in red because it's the one you'll use the most. The power rule. This is something, like I say, you probably won't learn this for a couple of weeks in your math class, but here's what the power rule says. The power rule says that if you take the derivative with respect to x of x to some power n, that is the same as, so what you do is you take the power and you bring it out front, so my power is n, and then you multiply that by x to the same power minus 1. Okay? This is the jam. You're going to use this a ton this year. All right? That is called the power rule. Okay? So again, the process is you drop the exponent down to the front, and then you decrease it by 1. Okay? So, let's clear that up. Okay, so that is called the power rule. What else do you need to know? Well, let's do an example of this. All right? So suppose I tell you that, oops, I wanted this to be a different color. So suppose I tell you that f of x is, I don't know, x to the 4th. Oh, well then the derivative of f with respect to x is, well, you bring the 4 down out front, and then you've got times x to the 4 minus 1 is 3. There you go. There's an example. Okay? All right. Next example. So, I did it again. All right. So here we go. Suppose we've got this. Suppose we want to find the derivative with respect to x of two functions being added together. Oops. No, let me write it this way. No, I guess we're using blue. Okay, so I want to find the derivative of f of x plus g of x. So it turns out this is the same as the derivative with respect to x of f of x plus the derivative with respect to x of g of x. For example, suppose f of x is, I don't know, how about x to the 7th? We'll do plus, I guess. Plus x cubed. All right? Well, then the derivative with respect to x of f is the same as just taking the derivative of this and adding it to the derivative of this. So the derivative of x to the 7th is 7x to the 6th, plus the derivative of x cubed is 3x squared. Okay? So when you've got terms being added, you can just take the derivative of each individual term. Okay? So that is addition. That's the rule for addition. All right? The rule for multiplication or subtraction is the same. Okay? So or subtraction. All right, so if this had been minus x cubed, then this would be minus 3x squared, okay? There is a rule for multiplication and division that honestly doesn't seem to come up that often. I've seen it come up once or twice. I think that by the time we need it, you'll have seen it in math class, so I'm going to not worry about that right now, okay? If it does come up, there are other videos on my website from, I don't know, My Secret Math Tutor, I think is the videos I posted, or maybe the organic chemistry guy. I don't know. There's videos there. Look them up if you want, all right? It's AP. Figure it out. All right, let's see what else. I did it again. All right, here we go. So how about this? Suppose I want to find the derivative with respect to x of some constant c times f of x. All right, well, it turns out that is the same as c times the derivative with respect to x of f of x. All right, what does that mean? Well, that means this. It means that, or well, I guess probably let's do an example. So example. So we already learned how to take the derivative with respect to x of, I don't know, x to the fifth, right? Suppose I want the derivative of 2 times x to the fifth. Oh, well, that's the same as 2 times the derivative with respect to x of x to the fifth. So that's 2 times, well, let's see, that's, derivative of x to the fifth is, 5x to the fourth, sorry. 5x to the fourth, which is the same as 10x to the fourth. Okay? All right. I guess we should probably do chain rule. So let's do that real quick. All right, this one actually does come up from time to time. Let's do this one green. The chain rule. All right, I'm actually going to use math notation on this one. So suppose I want to find the derivative with respect to x of f of g of x. All right, so it turns out that that is the same as f prime of gx, or f prime of g of x, times g prime of x. All right, that's a little bit tough to write out using this d dx notation. There is a way to do it, but it gets a little bit ugly. This is the easiest way to do it. So it's the chain rule. So you take the derivative of the original function, and then you got to multiply it by the derivative of the inside function. So here's an example. So suppose I want the derivative with respect to x of 3x to the 7th. All right, well, there's a couple of ways you could do this. You could do 3 to the 7th and figure out what that is, and then, you know, so you'd have whatever 3 to the 7th is times x to the 7th and take the derivative. The other way you can do it is this. Take the, so pretend this was just an x, right? So you'd get 7 times 3x to the 6th, right? So that's this part, right? So, but now I need to find the derivative of this. I need the derivative of this, right? To get this thing here. So the derivative of 3x is just 3. Okay? So, that is that. This was probably not a great example of this. I probably should have waited and done a trig example. So I'll do that in a minute, all right? So before we do that, we got to learn trig rules, all right? So here we go, trig rules. So it turns out that the derivative with respect to x of sine of x is simply cosine of x. And it turns out that the derivative with respect to x of cosine of x is negative sine of x. All right? So again, you'll learn more about this in math class. For now, you just need to know those. Okay? Cool. Cool. So again, remember, each of these derivatives just gives you a new function, right? So here I started with a function, sine of x. Taking the derivative of it gives me a new function, right? So that's the deal there. Those are probably the only trig functions you're going to need for this class. I don't think we'll ever need tangent or cotangent or any of those guys. So that should be good. You occasionally need trig identities, but pretty rarely. All right. Finally, I think the last rule we need to learn is exponential functions. So, e to the x is actually a really cool function because it is, I believe, the only function that we know of whose derivative is equal to the function itself. That means at any given point, the slope is equal to the value of the function, which is kind of neat, right? So if you graph e to the x, it looks like this, right? And since the value of e to the 0 is 1, that means the slope at that point must also be 1. Cool? Oh, no, that's not all what the graph looks like, though, is it? No, that is not. That's embarrassing. Let's try this again. The graph of e to the x looks like this. And at x equals 1, the value is 1, so the slope there is 1. There we go. Sorry, I graphed log instead of e to the x. Okay, so that's that. Let's do 2 more examples of the chain rule real fast, okay? So, chain rule part 2. Okay, so again, here's what the chain rule says. The chain rule says the derivative with respect to x of f of g of x is the derivative of f evaluated at g of x times the derivative of g of x. Okay, so let's do some examples. So suppose I want the derivative with respect to x of, here's a fairly common thing that might come up. I don't know, let's do sine of 3x plus 2. Okay, so here is f, and here is g of x, right? So what I want to do is I want to take f prime. So if f is sine, then the derivative of sine is, what did we say? The derivative of sine is cosine, right? So the derivative of sine gives us cosine. So that's my f prime, right? Of what? Oh, of g of x. That's a terrible color. I won't use that again. Of g of x. So g of x is, oh, just 3x plus 2. Right? Times, I'm out of colors here. I've used too many colors. We're going back to, I don't know, we'll do blue again. Times g prime of x. Well, look, this is g, so what's the derivative of that? Well, remember, we can just add, right? So let's see, the derivative of 3x is 3. Derivative of 2 is 0. So there's my answer. So simplified, you'd get this. 3 times the cosine of 3x plus 2. Okay? Let's do one last one. So let's do the derivative with respect to x of, how about 3e to the 6x? Okay, well, the 3 doesn't do anything, so I can pull the 3 out. Okay, so what I'm going to do then is, so the derivative of, I'm covering this with my hand like you can see what I'm doing. So the derivative of e to the x is e to the x, right? So I'm going to take, so I get 3 times e, the derivative of e to the x is e to the x, so the derivative of e to the 6x is e to the 6x times the derivative with respect to x of 6x, right? So this is my chain rule part. I'm taking the derivative of the inside function, right? And the derivative of 6x is 6. So this is 3 times e to the 6x times 6. 3 times 6 is 18, e to the 6x. All right? So there you go. Crash course in calculus, 20 minutes. Bam! Other videos are posted if you need more examples or details, all right?